Hello again, everyone. I'm Lovejoy, and we're back. I'm joined with Mike Manfredi and Stephen Watanabe today for a very special edition of Fractal Democracy, or Fractal Governance, What, Why, and How. And today we're going to be going in a slightly different direction and discussing some of the magic behind another project, the Clarion OS software. And so before I say anything completely weird and inappropriate or inaccurate, I'm going to turn the mic over to Mike and let you introduce us to provide some context, if you could, for what we're going to be tackling today and how it fits into everything else that we're working on. With,
Sure.
Yeah.
So we are in very early days of Clarion, ClarionOS, and I've been looking for. There's a lot of duck feet moving under the water in the background to just mash an analogy into oblivion. And I wanted to share some of that as we get it done, kind of like we've done with Todd and his demos. Standing in transparency, we want to get out there what's actually happening in the background. So Stephen has been tasked with the early days of how are we going to take Dan's ideas about ClarionOS, this decentralized communication platform, and start to turn that into something that, what is that going to look like technically? So he's been doing the very early research into what's that going to look like, what are the technical problems, what are the technical questions we need to answer. And today what we'll be covering is data synchronization between nodes. This will be a very technical presentation. So if we have technical people out there who'd like to ask questions, please don't hesitate to do so. But this will be a very highly technical background on how we're approaching the problem of syncing nodes in Clarion. Stephen, any other preface, the background you want to put on what we're about to see?
I think that's a good introduction.
Okay.
Cool.
All right, take it away.
All right. So the main assumption that I'm making about the network that informs a lot of this is that the network is unreliable and nodes are only connected intermittently. That has a lot of implications on how the communication system has to work, and it makes a lot of things more difficult if you don't have a centralized server that you can connect to at any time. Anyway, so for data that needs to be shared between multiple nodes, this semi-standard method is to use something called a convergent replicated data type. There are two forms of this. One that uses a set of operations and streams them between nodes, and another that takes the state of two nodes and synchronizes them. The operation-based CRDTs are somewhat inconvenient because they place strong requirements on the network. That is, they require the operations to be delivered exactly once, and thus they are not really suitable for our purposes here. So for a state-based CRDT, the general method is that whenever two nodes connect, they have to exchange enough information to bring their states into agreement. So that operation of synchronizing the states of the nodes essentially defines a function of the two states that produces a common shared state that the nodes will have after they synchronize. So in order to guarantee that this will bring all the nodes into agreement eventually, that function has to have some mathematical properties. Specifically, it has to be commutative. So when two nodes send their states to each other, they both have to come into if it weren't commutative, then they might end up in different states even after that communication, because one is computing f of x and y, the other is computing f of y and x. It also has to be associative, so that means that the result of the function does not depend on the order in which nodes synchronize with each other. And it also has to be idempotent, so that if two nodes are already in the same state, then synchronizing will not change that state.
Yeah, let me jump in and make sure. Lovejoy, I'll use you as the bridge here. So this is again talking about peer-to-peer, right? So we've got questionable connectivity. It wasn't called out here this way, but think about the kind of network we're trying to do. We're setting up when we've got client browser peers, right? Low performance peers talking to each other. We've got connectivity, questionable connectivity, limited connectivity, and so this is all about how do we get the data that's changing on one node and potentially changing on another node and have the same state end up as a result on both nodes.
I'm with you so far in terms of the objective and partly with respect to the solution.
Perfect.
Yeah.
Right. So this is fairly well-known background that is necessary to understand how the higher level Clarion is, how to understand the specific details of how Clarion is working. This is so far it's fairly abstract. We'll get into more concrete in a bit. So defining this in terms of a function of the two states makes the description of it fairly easy, but it's not efficient because you don't want to send the complete state of each node every time you synchronize. So most large states can be broken up into some sort of key value system. So if we do that, then we want to make sure that when we synchronize nodes, we only send the data that's different between the two, and rather than the complete state. And that will allow us to do it with a much more limited bandwidth. So the algorithm for doing this is to use a Merkle tree. So every node in the tree represents a range of keys. The root of the tree represents a range that covers every possible key. When the children of a node have to cover the same range as that node, and the structure of the tree can't depend at all on on what keys are actually present or not. So the basic idea is that if you compare the hash at any given node between two trees, if it's the same, then that implies that all the keys within that range have the same value, and you don't need to look at them anymore when you're syncing. So the algorithm for synchronizing is that a node can send a message to another node. We start with one arbitrarily sending the tree node for the root, and that will give the range covered by that and the hash of that node. Another message that you can get is a key value pair. That is the leaf function, and that terminates the algorithm. Or you can return an ACK, which just reports that, yes, I received it, and there's nothing to do. So if a node receives a tree node from a peer, then you have to respond with messages that cover the same range as that node. So there are several options for that. If the hash that you hold is the same as the hash that the peer has for that key range, then you can just respond with an ACK, and that will stop the descent into the tree. If you get if it's a leaf, then you can respond with the key value for that leaf. And finally, if it's an internal node, then you can then you can send the children of that node back to your peer. And that will drop one level into the tree. If you receive a key value pair, then depending on whether it's the same as what you already have, you can either send back your version of that key value pair, or you can send back an ACK. So the value itself has to have a merge function, and it must be a CRDT itself. Assuming here that it's small enough that just sending it both ways is sufficient, has sufficient performance, and that breaking it up into smaller pieces is not going to significantly improve performance. And if you receive an ACK, then you don't need to respond at all. And finally, what the ACKs do is that they make sure that every node knows when it has received responses for all the messages that it has sent. So that allows each side to know when it is in sync with the peer node. So the number of messages that have to be exchanged in order to run this algorithm is bounded by the number of differences times the depth of the tree. That is the bound that applies when the number of differences is small, because for each one you have to traverse a complete branch of the tree. As the number of differences becomes much larger, then the number of messages is bounded by the total number of key value pairs. That is because the branches begin to start sharing paths through the higher layers of the tree. So so that reduces the total number of messages that have to be sent. The number of round trips required is exactly half the depth of the tree, because each time we send a message one way, it descends one level of the tree. And we can, for now I'm just descending a single level, but descending multiple levels is also possible, and that can reduce the number of round trips at the expense of consuming more bandwidth. That is a trade-off that can be made later. Clients can add optimizations while still being compatible with older peers. All right, so I've thought about it and come up with a few key types that are likely to be common. So a sequence number is an integer in a range from 0 to n, and this is efficient. It can be used for a number of purposes. For example, in Clarion, if you have public posts by a single author, that author can assign a unique sequence number to them easily. And that allows us to use the sequence number key type, which makes the Merkle tree structure be perfectly balanced and have the minimum possible depth, thus reducing the amount of data that needs to be sent on synchronization. Another key type that is more general is to use a cryptographic hash of some data. So this is still very efficient, and it can represent anything, but the data will be in no particular order. And so that makes it hard to synchronize, for example, only messages in a particular date range. So only messages in the last 6 months, for instance. The most general possible key type is an octet string. It can represent anything that we want in any order. The main problem is that the performance of synchronization is going to be dependent on the length of the string, and there's no hard upper bound to the time that it takes because of that. All right, so how does this apply to Clarion? I have a few things that I have considered, a few things that are for the future, and I have not yet tried to implement. So the ones that I've considered are public posts and identities. So as I said before, the public posts are keyed by a sequence number assigned by the creator of that post. Let's talk about that a little bit. So each poster creates a number of channels. Each channel is synchronized independently, so anyone can subscribe to a channel, and anyone who's subscribed to it will receive a copy when they talk to another node. The key is just the sequence number. Do I have anything more about? So that is a pretty straightforward mapping onto the CRDT. So I don't really have much to say about that. The identity is considerably more complex. So the main thing an identity provides is a public key that can be used to sign messages. In addition, the key can be changed. So you can periodically update your key to either revoke a compromised key and replace it with one that is not compromised, or just periodically rotate it just in case, as is common cryptographic practice. So how do we represent, wait a minute. Okay, so there are a few ways this can fail. If the owner of the key loses access to the private key, then he can no longer sign messages and he needs to reset it somehow. If someone besides the owner gains access to the private key, then we need some way to revoke the key to invalidate the messages that were signed by the imposter. And finally, sometimes the owner of a key can sign something that he really shouldn't have signed, and we need a way to revoke that specific signature. That of course, is heavily dependent on the exact nature of what was signed. So the base case for fixing all of this is to just create a new identity and copy all the data from the old identity. That is guaranteed to work in all cases. It's easy to understand what happens. The downside is it requires everyone who's subscribed to that to take manual action to correct it, to use the new identity instead of the old one. But I'm confident that if we don't make the recovery mechanism sufficiently simple, users will just fall back on this because it's the obvious thing that they'll think of.
Stephen, when you say manual action, why must this be manual? Are you just saying if it's not automated, it's by default manual?
Well, right, because this is something that works and requires no support at all from the software.
Okay.
And so if you don't make the recovery mechanism easy, users will just do this.
Okay, makes sense.
And it does have the benefit that it's a fallback if everything else fails. So we can always make it, we don't have to make sure that the other reset mechanisms are absolutely perfect. They just have to work sufficiently well the vast majority of the time. Okay, so the main principle of Clarion is that you only trust a small set of friends. So the recovery process has to somehow rely on that. So what I came up with is that the identity is represented as a linked chain of keys. So each key is signed by the previous key, essentially forming a structure similar to a blockchain. And the identity block, in addition to the key itself, it provides a list of trusted friends who can be used, whose signatures can be used to recover the key. So in order to do this, you define a threshold of signatures that can be considered valid on an identity block, even without a signature from the owner. And that allows you to reset your key as long as you can convince your friends of your identity in some way. And in addition, if a key is compromised, we can rely on the friend signatures in order to disambiguate and decide which one is the real one and which one is the imposter. So the basic procedure, if you lose the key, is to create a new block. Somehow out of band, you have to then convince your friends of your identity and ask them to sign it. Once they sign it, that new identity block will be considered valid by all clients and propagated through the network. So the procedure here is essentially the same as a hard reset, except that in terms of what the person who's doing it has to do. That is, you create your new key, you tell all your friends about it, and they update to use it. The only difference is that it will then automatically, once you get that far, it will then automatically propagate to all subscribers. if the key is stolen, then you have a similar process. You can create a new block that overrides the attacker's block, and rely on your friends to disambiguate. And finally, the last problem is that if an attacker can trick some of your friends into signing an identity block, either in some way, then you can recover from that just by letting them know somehow. As long as you have a way to convince them of your identity that is more convincing than Mallory's imposture.
Stephen, this is interesting compared to Msig. This is kind of a dual threshold where you've got your minimum threshold to do a identity update, but you've also got this, in the case of an attack, the more signatures win, the higher signature wins, or the greatest number of signatures wins. That's kind of a cool setup because you could have a larger set of friends who could play this game with you. You have to trust them all, but a small number could do the recovery, and you could have almost as a backup a larger number that would make this attack almost impossible. Is that accurate?
So I was also thinking of something along the lines of if they interact with you for a sufficient amount of time using a specific block, it will automatically the software will automatically sign it, and somehow, and probably weight that less than an explicit signature, but. So.
Interesting.
Because I remember one of the main problems with PGP was getting people to sign the keys, right?
Mm-hmm.
So the process needs to be automatic most of the time.
Yeah, interesting.
And the manual process, with the manual process only being invoked when there are actual problems.
Who's this Bitmaster guy? I don't think I know him.
I presume it's Dan. Let's hope. I don't know if you want to read that, if it dovetails into the current conversation.
Yeah, Stephen, you want to read the comment at the bottom of the screen?
I can't see it with my screen shared.
Oh, no problem.
To be more general, two nodes are only attempting to synchronize on a common substate, and not all nodes need to have all state, which I think.
Yeah, that's pointing at subscriptions. You're going to be subscribed to channels.
He also said, "Go team."
Right. Yeah. So I guess that would talk about. So every node decides what channels, what identities it's interested in, and would only synchronize those with its peers. So these CRDTs are individual objects that are synchronized independently of each other.
Yeah, even types. You can synchronize. Yeah, I think that independence, you've got identity blocks, you've got posts, you've got comments, you've got different things that don't need to be part of a whole. They're independent things that can be synchronized.
Right, and negotiating which things to synchronize is another problem that I haven't really addressed yet. But I don't think it's too much of a problem. Okay, so the method of representing this identity chain as a CRDT, so it has to have a few properties. So if a block has the potential to be the best block, it has to be propagated at least to friends so that they have the chance to sign it. In addition, you can't propagate an unbounded number of blocks. Just having the key should only allow you to sign one child of a given block. So in order to represent this, first of all, the whole chain is represented by a key value set where the key is the block height, which is another form of a sequence number. The value is a set of candidate blocks consisting of at most one block for each possible signer. Whenever you sign a block, you assign a sequence number to it, and the one with the highest sequence number is retained. That allows two friends to sign a block independently, even if that isn't the best block when separately, because it only has one signature. When you combine them together, then you'll have two signatures, and that will be preserved. And that may then become the best block. That allows us to discard all but a finite set of blocks, thus keeping the total size of the value bounded. So that allows us to merge two blocks that have the same parent. Once you know what the best one is at an individual block level, you can then recursively walk over it and pick the best fork. Doing it in this exact order has some issues, but it does accurately describe what the final result should be. And I haven't quite gotten the details of the algorithm yet. So the identity has several uses. The first is to sign updates to the identity. So each identity block has to be signed by the key of the previous blocks. The identity is also used to sign public posts. That's completely straightforward. You just take the key and sign it. The thing that I'm working on right now is figuring out how to use the identity to authenticate a connection between two nodes. So there are two main scenarios here. So if Alice is willing to accept incoming connections from any other node, then that means that Alice needs to authenticate to anyone who connects, to prove her identity to anyone who connects. That's pretty straightforward because all Alice has to do is to provide a copy of her identity chain to anyone who connects. The person connecting can then verify that her identity chain is consistent with what he expects to see. And then that identity provides a public key. Alice holds the private key, so authenticating is trivial at that point. A much more difficult case is that this is a scenario where Alice only wants to accept connections from friends. So in this example, so for a specific example, Alice is willing to accept an incoming connection from Bob only. So we're going to assume, first of all, that Alice and Bob each know at least one block of the other's identity chain. That's the minimum necessary to do any sort of validation. I don't see how you could reasonably get away with less than that. You could also require it to be a recent block, not just any block. We also assume that they each know their own complete identity chain, and they know their own current private keys in order to sign. We do not assume that they retain private keys from previous, from older private keys from their identity chains. So it's possible that Bob has an identity chain that was forked off of Alice's chain by a malicious attacker. In that case, Alice has to prove that her identity chain is better than the one that Bob already knows, as using the system of showing that it has more friend signatures. So the properties that we want to achieve from this are that an attacker can't connect to Alice pretending to be Bob, nor can he accept an incoming connection from Bob while pretending to be Alice. And he also can't do both simultaneously, which would be a man-in-the-middle attack. These are fairly well-known things, and TLS supports them. So I want to avoid inventing my own protocol for that, since it's very difficult to do right. And it is a well-known problem with known solutions. A more difficult case is the final guarantee that Mallory can't exploit the protocol to learn things that he doesn't already know. So specifically, if he connects to an endpoint, he shouldn't be able to learn that it's Alice. If he receives a connection, he shouldn't be able to learn that it's Bob trying to connect to him. If he knows that he's connecting to Alice, he shouldn't be able to learn who Alice's friends are. And the same applies, he should also not be able to learn who Bob's friends are. That is a hard problem, and I'm not sure that it's completely solvable. And that's about where I'm stuck right now. So I guess that's about all I have for today. Any questions?
All right, cool. We'll give the chat a few seconds to ask questions if they're there.
Yeah, that's a lot. Well, I just think about all the real-world application potential. So that's the direction my questions are going to come from. Like when you talk about intermittent connectivity and low data requirements and stuff like that, like maybe you could provide a little context for like just exactly what might the minimum bandwidth requirements be like? Can we see Clarion functioning in like a sort of ad hoc network with pretty primitive technology, or like maybe what's the benchmark for?
Well, so my main concern is making sure that that it scales in a reasonable way. So in a more constrained environment, you would be able to use less data. You would be able to send fewer messages, but you could still send some. And as you have more bandwidth available, you can send more and more messages. And it's important that it should scale in a reasonable way. Like if you send 1,000 messages, that shouldn't take 1,000,000 times more of the bandwidth total. So I haven't really gotten into specific measurements of how much. I'm more concerned with big O complexity.
Gotcha. Ami says, perhaps, I think referring to your last example where you were saying that's as far as you'd gotten. He says, perhaps if they meet in person, Alice and Bob, they can be sure the account represents the real Alice and real Bob? Question mark. I don't know if that was apropos to your.
So if both Alice and Bob have each other's current identity chain, if they've synchronized that much and they both know it, then it's definitely possible to achieve this last one. So the case that is hard is that, for example, Bob only has the previous block of Alice's identity chain, not the current one. Alice has to provide her new block and a signature from using the key for that new block. I want to avoid making it so that Mallory can also get access to that new block.
Yeah, as far as bandwidth, I think it can be pretty hand-wavily said that this is largely what we're talking about sharing here is communication, right? Human-generated content, communication content. So text-based,
yeah.
Right.
Yeah.
So it's going to be extremely limited, and the only part that's not necessarily
until people start sending video.
Yeah, exactly. Until we start expanding what gets sent. And the only other place that would apply is if you're subscribed to a ridiculous number of people who tweet all the time, you kind of put yourself at the hub of a bunch of communication, but all of that can be throttled because it's all known connectivity ahead of time.
Right, and presumably the network or the application could know almost your level of connectivity and maybe even, yeah, like you say, throttle, or like if I'm connected to a bunch of nodes that have really high throughput, then maybe I can do video, but otherwise it would just be like, you really shouldn't try to do video. That's not going to work, and you should just stick with text messages, or,
Yeah. And the hubs are the other place that shows up. Let's look at like a Twitter world where very, very well-known, very highly connected people tweet, and people are interested in Musk and government officials and heads of companies, right? When you have the big names, famous people and sports people, when you got all these famous people who lots and lots of people subscribe to, we're also going to be propagating that information through essentially relay nodes. So there are other times when bandwidth would be a consideration, but as Stephen said, ensuring that we scale kind of handles that. Go ahead, Stephen.
So that kind of scaling is not really a problem in this kind of network because you can get fan out from any number of nodes pretty easily.
Couple of questions from the chat here. One is Christopher Barnes says, kidding, but what is the anticipated timeline for an MVP of sorts? We knew this question was going to show up. Everyone's so excited about Clarion.
Yeah, well, I honestly have no idea. So what I have functioning today is a synchronization protocol for messages that operates on in-memory queues. It doesn't serialize it over the network. I have done some measurements to verify that it scales, the number of messages that are sent to synchronize scales as I expected it to. I also have some code for the identities, which is going to need to be completely rewritten. And I have some pseudocode for establishing a connection, which I'm going to probably rewrite multiple times because I don't even know exactly what I'm doing yet.
Yeah, I think this is the perfect time to come back to. I hope I said this at the beginning, but beat the drum, beat the mantra. I'll just go with bad analogies today. This is a good time to come back to. We're coming from transparency. Clarion's about being a transparent open source project, and these are very early days of this technology. So there are a lot of unknowns, and Stephen, thanks so much for organizing the information into this presentation and taking the time to walk us through it. But also thanks for your humility to say I don't know at a bunch of points here. This is very early days, and Stephen is spearheading actually getting answers here and even formulating the right questions.
Yeah. Yeah, absolutely. I'm happy that you guys are willing to share this information, and I hope it's not lost on people that this really is very bleeding edge, never before been tackled, or not in this way, at least. I think the right questions haven't really even been asked until now. So really cool to see the thinking that goes into this.
Yeah, in fact, to put this in even further context, Stephen, roughly how long have you been devoted to this work?
A bit over a month, I think.
Yeah. So this is like Dan plus Stephen for a month, and this is what we have. So it's quite a bit for a single person in a month.
This is sophisticated, to say the least. Question from Ami. Can they use EOS to publish their identity, and Clarion can verify their ? Perhaps leveraging Eden On EOS identities as high reliability vouching accounts?
So I did consider it, and I think that should be a valid option. I think we should have I think there should be a fully Clarion native identity system, but leveraging some sort of trusted third party like the EOS blockchain is also reasonable, and I think it should be supported.
Yeah, there'll be the credibility built in the Eden community by delegates just as an outcome of having power delegated to them by the Eden community. It's going to be a big deal, and we're definitely looking to leverage that credibility in numerous ways, and this could easily be one of them.
Got a question from Jay Taylor. As you design friend-of-friend identity architecture, isn't this a new standard for an API? Has Clarion Architect considered making a W3C? Because needed hypermedia APIs, we need a blockchain API. Make of that as you will.
So I'm not really the right person to be designing that sort of API.
But yes, we agree. It would be awesome to do that.
Yes.
This is innovative and very interesting, and it would be cool to head in that direction. No current plans. We've got a billion things to do and 7 people. But yeah, it's a great idea.
Cool. Ami says, thank you for the presentation at this early stage. Thanks, Ami.
Thank you, Ami, for your work on the portal and involvement in the second trial election. Super excited to see the final outcome. Appreciate you being on the live stream.
Let's see if there's any other questions percolating up in my mind. unless you want to elaborate on anything else, Mike or Stephen.
I think we're good. I'm glad we got a couple questions, and that's most of what we wanted to share. Again, Stephen, thanks for taking time out to pause your work and put all this into English words and take the time to share it with us. There's always a need to bridge the gap from code to the community that we're building this for, and I appreciate the time you put into making that happen.
Yeah, absolutely. And so should we expect to be continuing with more Clarion content in the weeks ahead, or what do you guys see that you want to do for?
Yeah, I think we'll have checkpoints. I don't want to put the burden on Stephen to have something every 2 weeks, but I think we'll hit milestones where we'll have something significant to share. And Todd and Stephen both have the wide open door of, as soon as there's the next thing to share, they'll be featured on the live stream.
Cool.
We're also doing work in the background for what you might call book features, distinct from software features. So what are the things that Dan has talked about in the book that really do need attention, really do need to start to become an Eden mechanism to round out, to make a governance complete. There are things that we're going to want to do as a community that really do need mechanisms and don't have them yet. We've got ideas. The book lays out a lot of them. But before we trip over them and all of a sudden need something, we're trying to prioritize what are those things that we're going to need, what are reasonable mechanisms, kind of like the flow of funds we did for reporting a profile arbitration. We're getting those things in order so that we are sure that we're addressing those things in an order that has the minimum opportunity to create an emergency.
Awesome. You said what did you call them? Book ideas? Like
book features.
Book features.
Yeah, they're features of the system, but they're not yet software features. They're not on the software roadmap. They're features we need at the very high level that eventually do need to become software features.
Cool. Well, tell Brandon Fancher that I'll be pestering him more about book features for the Eden OS updates now that I know.
Well, yeah. We may have an update to the VO3 features. He and I are going to be reviewing those later today. But that's the high level. The book features are what I'll be talking about a couple weeks from now. And you can pester Brandon whenever you want. He's very pesterable and knows a lot.
Mm-hmm. Yeah, he's fun to pester. Well, cool. Thanks again, Stephen, for showing up today and helping us try to get our heads around this. I think I learned something.
Cool.
And even though a lot of it's completely beyond me, and hopefully other people will get a lot out of this and be able to see what's being worked on behind the scenes with Clarion. I know people are really hungry for any information about Clarion right now. So
yeah,
thanks. And thanks, Mike, for helping to translate as much as possible.
Yeah, absolutely. Your commitment and reliability are very much appreciated, Lovejoy. This is a lot of fun to do, and I'm really glad we can get this out to all the people who want to hear it.
Absolutely. All right. Well, we'll see y'all next week with Brandon Fancher, and 2 weeks from now, back again with Mike, and who knows what other tricks he has up his sleeve. So until then, adios.